Uh, Good morning. So today we are going to discuss the topic LED interfacing with 8051 microcontroller. So this topic is also from uh, EC305 sixth module. And apart from LED, we will also discuss about 7-segment display in this chapter. So basically, 7-segment display is also a combination of LEDs. That is why I just put the title as LED interfacing. Now, about the concepts of LED. LED or light emitting diode is a solid state optical PN junction diode which emits light energy in the form of photons when it is forward biased by a voltage allowing current to flow across its junction. And in electronic, we call this process called electroluminescence. So this is the band gap diagram and the concepts. So here we can see this is the excited electron by applying forward bias, and when there is a movement from electron from here to here, it will emit a light with a wavelength lambda, and the relation between wavelength and band gap is hc by lambda equal to ec minus ev, which is called energy band. Light emitting diode is a semiconductor device used in many electronic devices, mostly used for signal transmission. It is very cheaply and easily available in variety of shape, color, size. Basically, the color depends on the wavelength. So wavelength depends on the band gap because H and C is constant. That means by adjusting this band gap, we can create different colors of LED. This is the symbol of LED. It's like normal diode symbol. The only difference is that it's having a notation for light emission. And the positive part is known as anode and the negative part is cathode. Usually the anode will be lengthier than the cathode. The only way to know the polarity is either test it with a multimeter or by carefully observing inside the LED. The larger end inside the LED is negative. Inside LED, this is the larger end. This is bigger. This end is negative and the smaller end is positive. Or otherwise, in outside, the length, more length for the terminal, it is positive. Less length means it is negative. And this is the connection. Basically, two-way we can connect LED to microcontroller. In first, here, the anode is connected to the peripheral and cathode is connected to the ground through a resistor. Second type of connection where cathode is connected to the peripheral. In that case, anode is connected to a positive supply and with the help of a resistor. And this resistor is known as current limiting resistor because there is a power rating for each resistor or diode. So if the current from microcontroller drawing to the diode is more than this rated current, the LED will get damaged. So to remove that, we are using a current limiting resistor. These are the basic applications of LED: sensor application, mobile application, sign application, automotive users, LED signal, illumination, indicator. And we already discussed about these connections. So this is the current limiting resistor. And this is the equation which is connecting the current and the resistance and the applied voltage. Now, we will do a program where we can interface LED to microcontroller, and also we can create different types of state machines in LED. So this is the circuit diagram. So here we can see this is 8051 microcontroller, and in this microcontroller, in port 2, I connected LEDs. So total 8 LEDs are available in this. Okay, and in right now I am going to do a program for a ring counter. So right now I did a program for ring counter, and here I just bypass these locations 002 to FH, because those locations we are basically using for interrupt service routine. So I just skipped those locations and I started my main program from location 30H. And here I'm using port 2 as output port because I connected my LEDs to port 2 and just initialize the accumulator with 0 1H. Then in this loop, I copied the value in the accumulator, then I right rotate the accumulator, then I just called a delay, then I repeat this step. That means this 1H value will rotate continuously. And this is the loop for the delay. Now let's see what happens in the hardware. So I am going to upload the program. So I copied the hex file, I run it. So here you can see there is that one is shifting from one LED to another LED with a delay. So this operation is called ring counter state machine. Like that, you can interface LED to microcontroller and we can create different kinds of state machine. So this is the example for LED interfacing. And this is ideal kind of cases, but in actual case, we need to check the current rating and we need to connect a resistor that is limiting the current through the LED. So now we will start another application of LED, which is 7-segment display. So basically 7-segment display using this display we can represent numerics, that means decimal digits from 0 to 9, and also different characters in the alphabets like A, B, C, D, E, F, G, H, I, J. K is not possible, L, M is not possible, N, O, P, Q is not possible, R, S, T, U, V, W, W is not possible, X is not possible. So like that, these are the limitations of a 7-segment display. It can display all the decimal symbols, but some alphabets using 7-segment display, it is impossible to display those alphabets. So this is the possibilities of 7-segment display. Now the configuration of 7-segment display. Two types of configurations are there. One is common cathode, another is common anode. So already we know that which one is cathode, which one is anode. And in LED, we already discussed about cathode and anode. Negative terminal is known as cathode, and the display where cathode connections are connected to a single point, which is called common cathode configuration. Here, the port we can connect to the anode terminal. So this is one configuration of LED 7-segment display. Another configuration is common anode. Here, all the positive terminals are connected together. So this one is kept open. Here we can connect the peripherals of, the output ports of the microcontroller. So two configuration, common anode and common cathode, and this is the arrangement of 7-segment display LEDs. So usually we have 1, 2, 3, 4, 5, 6, 7 segments will be there, and each segment is having an LED. And this is one configuration, common cathode 7-segment display configuration, B, C, D, E, F, G. Total 7 segments. So this is order A, B, C, D, E, F, G. Okay. And here also common anode configuration. Here all the positive terminals are connected and connected to the VCC. If common cathode, all negative terminals are connected together and it is connected to ground. So in the case of cathode, all are connected to ground. In the case of anode, all the peripherals are connected to the VCC, and this is kept open, and this negative peripherals or terminals will be connected to the microcontroller. And this is the state machine making. Suppose if I want to create symbol 0, 1, 2, 3 up to 9, we can copy hexadecimal number according to the connections into the hardware. So it depends on the connection only, this hex value will come. So I can give you an example in my case for LED interfacing. So this is a 7-segment display configuration. Here I connected port 2 to 7-segment, port 2.0 to A, 2.1 to B, 2.2 to C, 2.3 to D, like that, 2.7 to F. So when I make a state machine for this, I can display different numbers in this 7-segment display. So already I told you about the ring counter program. The same kind of program I am going to do here also. Here, now my output port is port 2, and I just bypass all these locations. Then I started the SSD loop, solid state device, solid 7-segment display. Here, move A, 3FH. This is for the symbol 0. Then I will copy that value to port 2, call a delay. So till this time, 0 will display in the 7-segment. And after that, 1. So 06H is the code for 1. Then I will call a delay. So 1 will display for this much time. And after that, 2 will display for this much time. Like that, we need to create the state machine. According to the state machine, we can create 7-segment display. So here, I can build this program. Then just upload this program. Okay, then run this program. 0, 1, 2, 3, 4, 5, 0, 1. So I just made state machine for values up to 5. Then I just copied this value through port 2 to 7-segment. Then made an infinite loop. So it will work like this. Now I will just tell you how I created these values. Let me explain that. First example, if I need to display 0. If I need to display 0 means, this is not clear, I will display with respect to the presentation. Suppose if I have to display 0, 0 means A should be on, B should be on, C should be on, D should be on, E should be on, F should be on, G should be 0. And I need to make the state machine according to that. For this condition, P2.0 is A in our hardware, P2.1 is B, P2.2 is C, this is D, this is E, this is F, A, B, C, D, E, F, and this is G. 7 we are not using, so this is always 0. We don't need to make any state machine for P2.7, any value for P2.7. So that means now for P2.7, this should be 0. This is always 0. And P2.6 will be 0. Remaining all values are 1. So that means 1, 1, 1, 1, 1, 1. So this is the value. So as you can see here, this is a lower nibble. This is F. Lower nibble value is F. And higher nibble is, this is a higher nibble, this is 3. So that means if you copy 3F to 7-segment display, we can display 0. So this is how we can create state machines. So like that, we can create values for all symbols. So here 3F corresponds to 0. So I copied 3F to the display. Then I run the code. That is why I am getting 0 as the first symbol. Okay. So this is what the method we are adopted for creating the state machine. Let us take an example, second example. Now if I need to display the symbol 1, either you can use B and C or F and D. In my case, I used B and C to display 1. Let us take the value. So here B and C is 1. Okay, that means here B is 1, C is 1, remaining all are 0. Okay, so this is 0, 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 and this is 0. So lower nibble value is 0, 1, 1, 0, which is 6, and this is 0. That means if you copy 0, 6H, 0, 6H to the 7-segment display, we will get symbol 1. So 0, 3FH value, 0, 6H if you copy, will get symbol 1. So that is why I copied 0, 6H as a second value. Then I copied that value to port, then I called it delay. Because of that, when I run this program, as a second symbol I am getting 1. So like that, we can continue the state machine creation. So this is about 7-segment display interfacing. Okay, now for this is the state machine I created for common anode configuration, common cathode configuration, where we are connecting peripherals to the positive terminal. That is why we are putting 1. In the case of common anode configuration, we need to connect negative value to the hardware. That means wherever we need high value, we need to copy 1. So opposite value. Application 7-segment displays are widely used in digital clocks to display the time, used for electronic meters for displaying the numerical information, used in instrument panels, used in digital readout display. So you already knows that there is a limitation in 7-segment that it is not impossible to display some certain characters using 7-segment display. So that is why it is not usually using for displaying the characters. Basically, for the numerical symbols only, 7-segment displays are commonly used. So we will wind up the session. Thank you.